In the following figure, there are two regular heptagons and a circle passing through A, F, H and M. Find angle JBM. You are watching Brain Exploders, the world where brain starts working. To solve this question, we will use some basic properties of regular heptagon and complex plane. All the interior angles of a regular heptagon are 5 pi by 7 radians. Any three consecutive vertices of a regular heptagon form an isosceles triangle in which equal angles are pi by 7 radians. Four consecutive vertices form an isosceles trapezium containing two interior angles and two angles of measure 2 pi by 7. Each side subtend an angle of 2 pi by 7 on the center of heptagon. A complex plane is similar to Cartesian plane in which there are real numbers on horizontal axis and imaginary number on vertical axis. Any complex number x plus iy can be represented on the plane as x, y on Cartesian plane. This number can also be written in polar form r e to the power I theta, where r is the distance between the point and origin and theta is the angle formed by position vector with positive x-axis. Sum of any two complex numbers is same as vector addition. Now come to the problem. Rotate this figure slightly such that line segment JK becomes strictly vertical. Now put this figure on complex plane. Center of the heptagon must coincide with origin. These are 3 points which form the required angle. To make the things clear, keep only those line segments which are necessary to reach these points and remove the rest of the lines. In these line segments, OA, AB, BC, OF, OG and GB are equal to the radius of circle which circumscribe the heptagon. Let these are equal to 1. EA and DA are equal to sides of heptagon and that's why these are not equal to 1. OC vector is equal to OA vector plus AB vector plus BC vector. Substitute complex numbers corresponding to these vectors to get the complex number of point C. OE vector is equal to OA vector plus AD vector rotated by an angle of pi by 7 in clockwise direction. Any vector is the difference of position vectors of its head and tail. To rotate it, we can multiply with e to the power I times minus pi by 7. Point F is the negative of a unit vector which makes an angle of pi by 7 with positive x-axis. E to the power I 5 pi by 7 can also be written as minus e to the power I times minus 2 pi by 7. In original figure, these points are B, J and M. Angle JBM is the angle subtended by point J and M on B. That is equal to argument of Zm minus Zb times conjugate of Zj minus Zb. Put the values of these complex numbers. On expansion, some of the terms get cancelled. In the next step, use the property e to the power I theta equals to minus e to the power I times either theta plus pi or theta minus pi to get the convenient exponents. Due to this, some more terms get cancelled. Any real factor of complex number does not affect its argument, so 2 can be removed. After that, there are some simple calculations. Finally, we get theta equals to pi by 7 and this was our solution. Let's move to our another question. Set S has 3 elements 1, 2 and 3. The Cartesian product S cross S indicates the set of 9 points in 2D Cartesian plane. 4 distinct points which could form the vertices of a quadrilateral have been randomly selected. Find the probability that they are vertices of a square. Try this question and comment us the solution, and if you have any question like this then please share with us. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.